This next example comes out of section 7.3, solving exponential equations. In this question we're asked to solve by changing the base, and we have an equation that says 5 to the x plus 2 equals 125 to the x. Now it would be possible to solve this graphically, to graph y equals 5 to the x plus 2 carefully on your calculator, graph y equals 125 to the x, make sure your window settings are fairly big, and find where they intersect. And you've done graphical solutions throughout the course in various spots. What we're looking to do is change the base, in other words solve algebraically. 125 is a power of 5. So if I leave the left side here alone, I can replace 125 with 5 cubed. Because 5 times 5 is 25, and then 25 times 5 is 125. So this is 5 cubed. So I then have 5 to the x plus 2 equals 5 to the 3x. Now if you get to this spot, you should be happy because you've basically done all the hard part of the question. It now becomes a matter of recognizing the fact that if I have 5 to the power of something equal 5 to the power of something else, those two exponents need to equal each other, meaning that x plus 2 needs to equal 3x. That becomes now more like a junior high problem where we're solving for x. So I've got 2 equals 2x and x equals 1. And that is the answer that you would have gotten if you did this graphically. We should check that our answer actually works. Later on in this unit, you'll run into some answers that are extraneous. But this one, I believe, if we do 5 to the 1 plus 2 equals 125 to the 1, we've got 5 cubed equals 125, which is true. 125 equals 125. I'm happy. This isn't an extraneous solution. It is the solution to that equation, and so that's solving by changing the base. Let's try another one of these. We've got 9 to the 2x equals 27 to the 2x minus 3. So hopefully you'll recognize both of these again as powers of 3. I can say this is 3 squared to the 2x, and this one is 3 cubed to the 2x minus 3. Replacing them with their respective powers of 3. So I've got 3 to the 4x equals 3 to the 6x minus 9. Now careful there that you actually multiply the exponents together. 3 times 2x minus 3 isn't 6x minus 3, it's 6x minus 9. That's the most common mistake I see made in this type of problem. Now I'm at the spot I want it to be, where I have a common base on either side of the equation, which means these exponents must be equal to each other. 4x equals 6x minus 9 means that 2x equals 9, which means that x equals either 9 over 2 or 4.5. And again, you'd want to check this and say, does 9 to the 2 times 4.5 equal 27 to the 2 times 4.5 minus 3? And you'll end up with 9 to the 9 on the left side, 27 to the 6 on the other side. Gigantic numbers, but if you punch them into your calculator, you'll find that they're the same gigantic number, which is what matters. And we have an answer of 4.5 or 9 over 2, which satisfies the equation.